Welcome back. Today we are going to go over how to upgrade this cheap, low-cost, $180 Amazon special Lamborghini. This thing does come all-wheel drive from the factory with some pretty miniature motors and gearboxes. These aren't even 550s in the rear motors. I have no idea what this little thing is in the front motor, but we're going to be swapping that out, putting 4 of a properly sized RS775 motor and gearbox setup in all 4 corners of this car. So you guys know the front, getting these motors fit in the front takes quite a bit of work. It's not the easiest swap. The rear, you pretty much just swap these in. There's nothing special. You can run the stock tires. They fit, no problem. The front takes a bit of work and modification. We're going to go over that in this video, but quick brief summary of what we're going to do. We're going to show you our custom 3D printed rims. These go with real rubber tires. There's a tube in here. This is pumped up to about 15 PSI. It drove really nice and smooth, as you saw in the introduction to the video. We had a few different options. You know, I bought a couple different size tires. This is the stock size. I was trying to keep it as close as possible, so I limited how much of the fenders I had to cut. I did end up having to cut a decent amount of the fender, but overall, you know, we're talking 4 RS775 gearboxes, Speedy Squirrel speed controller, 4-wheel drive, and it is running 40 volts, and it's running 100% power into these $40 for a pair gearbox combos. So follow along and I'm going to show you exactly how we did it. Be aware that we did have to custom 3D print more than just the rims. We needed this adapter bracket to fit the motors on the front. We had to print some different sized hubs to fit the rims. But that's really it. It was pretty basic. So I'll show you how we did it now. What we're going to be doing in the end, we're going to be running 4 RS775 motors and gearboxes. We're going to run a Speedy Squirrel. I'm not 100% sure this is going to survive 4 motors. I think it will. I know a lot of people have been running 4-wheel drive with it, but this is such a light car, and it's for my 3-year-old, and we're going to keep it pretty tame. It's not going to be that fast, so I think this speed controller is going to be just fine. Do know, if you are trying to run the Speedy Squirrel with 4 big motors, you know, 775s, 887s, and first gear delete, it has been having some reliability issues. It was not designed for that big of a load. Even though it can do 45 amps per channel, once you merge those in and try and get that 90 amps out of it, or realistically, you're looking at like 80 amps out of 4 big motors with the first gear delete. The capacitors are overheating and they can fail. So 60 amps total, 45 amps per channel. That's really what we're finding to be the limit. I need to get that description updated on the website. So sorry if you're watching this and the website's not updated yet. Speedy Squirrel, 4 motors, throttle pedal. Nothing too crazy. Here's our list. We're going to tackle electronics first, so that's speed controller. We're going to do everything possible to keep all the factory controls. So this car has lights, sounds, gear selector. We want to keep all that. Motors, hit on that. First build is going to be just stock RS775s. And then what we're going to do is we're going to show you how to swap in the 887s that we sell. We're going to stick with the 10-tooth pinion gear. So these gearboxes come with a 10-tooth, 32-pitch pinion gear. We're going to stick with that eventually. So we're going to get some speed data on stock. And then we're going to go with the motors we sell, which are a little bit higher RPM. Not much, but they do have more torque. So I'm expecting it to hold the speed a little bit better, but be pretty similar to these stock RS775 motors. For anyone who doesn't know what these gearboxes are, these are called RS775s. They're on Amazon. You get a 2-pack for $40. There's a bearing in the first gear and a bearing in the final drive gear. There isn't a bearing in the middle gear. They're pretty robust gearboxes. These come in those go-karts that I think go about 10 miles per hour from the factory. So these are 24 volts. I think at 24 volts with the normal size 11-inch diameter tire. These go about 10 miles per hour. And we're going to be running these at 40 volts for this build. So with about 9-inch tires. These are some pretty small wheels. And later in the video, I'll show you what we have for wheels for this. They're pretty cool. And that's traction. Well, batteries, didn't hit on batteries. I'm gonna run two 6 amp hour 20 volt DeWalt batteries in series for 40 volts, so 6 amp hours at 40 volts. So 6 amp hour lithium ion battery, drill batteries are good for about 10C, so 10 times the capacity. So that should be good for 60 amps, which is really where I'm hoping this lies, is 15 amps per motor, 60 amps peak. We'll see. I don't really know. This is the first time doing an all-wheel drive build with these motors and gearboxes. So that's our list. Let's start with electronics. I want to show you guys how to wire up this speed controller with the stock wheelie 12 volt speed controller. I'm going to get this all torn apart. I'm not going to do it on video. And then once I get torn apart and kind of know what's going on, I'm going to show you how to wire this up. Show you what the wires do and how to plug them in. So the first thing I do anytime I'm going to modify a car, I just make sure everything's working the way it's supposed to. This is brand new. It's been a foot of snow outside, so the kids have literally driven it on the deck a couple times and around the living room. Other than that, this thing's brand new. But wheels go, steering works. I'm going to go ahead and leave the steering motor in here for now. I have a plan to use a Hall effect sensor on the steering and feed that back into a controller, and then use a channel on the controller to control the steering motor. So I'm going to leave that gearbox in and keep it wired up in the event that I get around to writing the software to use an RC with a stock gearbox like that. And I think it's fine. I think that extra weight on the wheel will be good. So yeah, I'm gonna get started now. Here's the stock controller. So what we're dealing with is JR1922RXS. So if that's the controller you have, this video should help you modify your kid's car. Anytime you're modifying your kid's car, make sure you do it safely and you have a way to shut it off. So just keep in mind, if you're making these things go faster, you need to make them stop faster. Just a reminder. All right, so orange wire, or orange connector, battery power in. This was 12 volts battery, 12 volt lead acid battery. Let's see, so we have, so that's power in. Motors. So this must be rear motors, this is front motor, and this is the steering. All right, now we know. And then this connector over here is all the logic for all the control, shifter, power, and stuff up there. So we're gonna figure out which of these wires we need to keep, which ones we don't. But usually, the first two wires on these, the red one is the power out, and then the first one before it's power in. So if we feed 12 volts in here, and then white, I don't know, and then the last three are the direction, the forward and reverse. So usually, or forward low, forward high, and reverse. This has a gear shifter for just drive, neutral, or park, and reverse. And then one of these buttons is like a bunny and turtle, so that changes the speed mode. So I'm guessing something in here is changing the voltage on these wires. So we're going to take the meter and figure out what's going on there. And I'll show you how to walk through that. In the middle of disassembling, something I've always wondered is if I could just cut the original motor wire coming out of the controller, the wheelie controller, and run it into the left plus, left minus, which is the one used on my controller to detect polarity and voltage. So that's just two analog converters. So that just measures the voltage on these two pins to determine if it's in high, low, or reverse. And then the right plus, right minus is just there to get the right voltage for low. So if you only want, so everyone knows, if you only care about forward and reverse, and you're using a stock shifter and you're running 12 volts into it, you just need left plus, left minus. You don't need to wire up right plus, right minus. But yeah, this doesn't work. The controller clicked, and then so I'm feeding 12 volts into it. I don't know. It clicked once but didn't turn back on. Not sure. So I was hoping, it's like, oh well, if you could leave this in, push the pedal, and that's just an easy way to install. It doesn't work. Realized I had wired it up wrong, but I've been messing around with it. I still can't get it to power on. Yeah, there must be something in here making sure everything's hooked up right, and it won't turn on if something's wrong. All right, back to wiring. First step in figuring out what these wires do, I cut the red and the black wire and wired that to plus 12 and B negative. And now you see I have the lights on. So now I have the factory controls working. So next step is checking these last three wires and see if there's any voltage on those. If there's voltage on it, I'm going to use left plus, left minus to control direction. If there's no voltage on it and I have continuity based on continuity to common or battery negative or ground based on the gear selector position, then I'm going to go over here and use forward high and reverse and see if I get forward low. I'm not expecting to get forward low. I'm only expecting forward high and reverse. My kids aren't using low. Next step, check for continuity from these three wires, the yellow, green, and purple to battery negative, and see what I get. What I mean by continuity is zero overload. So if you're doing anything like this, make sure you pick up a voltmeter, multimeter. You can usually get them for a couple bucks at Harbor Freight. They work fine. This is a Klein Tool one. This is a decent, low end, upper low end, maybe kind of mid range. So the omega symbol, that's ohms. Hang on, let me mount the camera. Okay, I'm on ohms. Touch my probes together. Push your probe leads all the way in. Touch your probes together. You'll hear a beep and you'll get a reading. So low means you would have continuity. That means 0.0 ohms means there is no break in the path of these wires. So now you see overload. OL is overload. So now it means it's open. Whenever you're touching the wiring, make sure the speed controller is unplugged, unlike what I'm doing right now. If you short something that shouldn't be shorted, meaning you make continuity like I just showed you with the meter, you're going to fry something in here. So do not do that. Okay, now I have the meter here. Let me see if I can prop it up so you can see it. So if I touch battery negative, I get 0 ohms. I am going to turn this off for this. Actually, I'm going to check for voltage first. So now I'm going to switch to V, and typically you can measure AC or DC voltage. You click. A lot of meters come default to AC. Your non-engineering meters, like this one, this is for electricians, they come set to AC like your house. So you have to hit the select button and you have to get to DC. You're going to see some kind of bar. There's going to be some kind of indication that you've switched from AC to DC. So, if I check here, battery, I'm going to see about 20 volts. If I click select again, I'm going to see 0, or it's going to be jumping around doing some weird stuff because it's not AC. So that's 20 volts. My 12 volt output is 12 volts, 3.3 volt output, probably 3.3. All right, let's see if I have any voltage on any of these pins on this connector. All right, so the pink wire is 12 volts, so we're not going to want to use that for anything. The White wire, I'm getting nothing. Let's see, yellow, nothing. Green, nothing. And purple, nothing. Then let's just switch that direction there. Let's just see. Nothing, nothing, nothing. Let's see what neutral does. Should be no change. Okay, so now we know we're not going to send voltage into these logic inputs. So the forward high, forward low are over on this, everything on this side of the controller is all logic. So anything higher than 3.3 volts is going to damage the controller. So you do want to make sure that anything you hook up to this side is less than 3.3 volts to prevent damage to the controller. So now I'm going to turn it off and I'm going to switch to ohms. Okay. Oh, there we go. I have continuity. So I'll go back to my connector here and I'm going to see if I get anything. Nothing on any of those. So that was neutral position. Nothing, nothing, nothing. So that is unfortunate. I'm not getting anything. So I got it all taken apart. It took a while to get all the screws out. Followed the wires, and yellow and green were definitely forward and reverse. And then I was figuring out, so you look at the switch. Those three wires, the yellow, black, green, that's the direction switch. The yellow and green feed right back here, and the black goes to the pedal because you got to push the pedal. I always forget that. So yeah, wasted all this time disassembling this whole thing. Now I got to put it all back together. Yeah, so remember, push your switch when you're checking for continuity. All right. I got the car put back together, stock wiring. I didn't have to make any changes to the wiring harness except for cutting the green and yellow wire off, and then the red and black, which I already showed. So let me show you what should have happened before I went ahead and disassembled the entire dash. So I'm going to put the meter probe from B negative up here. That's stuck in the terminal block. FH, I'm going to push the pedal, and I get nothing. I'm in reverse. Switch to drive, and you hear the beep, and you see 0.4 ohms on the meter. So that's good. And then I can switch over here to reverse. That's open. Put it in reverse. Same thing. So that's how we check for continuity. If we're using, just a reminder, if we're using the forward high, forward low, or reverse, those three inputs, you're going to do battery negative into those, no voltage, or you can damage the board. Next step is to get the motor wiring and gearboxes all run here. I'm probably mounting the controller behind the seat in the back, so it's not going to be accessible. So I want to get all the wiring run first, and then the batteries are going to go here, and controllers are going to be in the back, out of the way. So once it's set up, I don't really need to access it except for software updates. All right, I'm going to get going on that and show you guys the progress. I have the wheels taken off, and let me show you what we're working with. These are the stock gearboxes. Remember, so these are the like RS 550s or 555, something like that. So these have a 550 motor in them, I think. We're going up to 775s. So size comparison, it's a bit bigger gearbox, it's beefier, it's got a 775 motor in it. Pretty big upgrade. And this is where the big disappointment came. Look, this thing, this was in the front. That. I was 100% expecting to see four of these motors in this car, and then this thing showed up. And that kind of ruined my plans because I thought I was just going to kind of put this gearbox in, even though it's a little bit bigger. Usually they fit. Yeah, let me show you what we're gonna do. What I did was design this adapter bracket. So it's got a hole, it's got a raised piece in the back that fits into this hole. So that kind of fits in there and kind of wedges itself between the steering arm and uses that hole. And then you kind of put one of these motors in. A bracket that goes right like that on the gearbox, kind of lines up. It's got holes cut out to line up with the indents or extrusions for the shafts inside the gearbox. And that goes together. That goes on here. And that kind of goes in there like that. And there you go. We're going to wire, just run these wires, replace these stock wires. And we got that big motor mounted in here. Now here's the problem. Rear tire meant to go with that flower style interface. Front tire meant to go with the miniature useless gearbox. So I could buy some of these and put them in it, but it's going to stick out. You still got this plastic tire and it's sticking way out. I don't like the way it looks. Here is the solution. What we have is a 9 by 3-6. So 6-inch rim, 9-inch, 3-inch wide. These come in at, realistically, they're like 8 3/4 inch diameter. And designed some Lamborghini style rims. My son, who this is for, picked out a green Lamborghini, and this was the style rim on it, and he really liked it and wanted me to copy it. So I copied it, printed it, made inserts. It's got a bearing in it. No idea if this is going to work. So what these are, they're printed in 2 halves. So this is face down and then this is face down. And then I bolt them, I put a tube in it, put the tire on it, put the backside in, and pumped it up to about 15 PSI. We will see how that works. I have no idea. So then you can put this tire on like that. Doesn't stick out nearly as much as that stock tire. It's got rubber instead of plastic. It's going to get traction, hopefully not too much traction, and destroy these gearboxes. The other big concern I have with this is the factory gearbox fronts, these mini things. This spins freely and does not spin the motor. So there's something in here that when the motor spins, it'll spin this output. So in the event that the front wheels aren't on the ground and the motors are spinning, this gearbox shouldn't strip. This one might strip, so that's kind of a concern. All right, now you're probably back to installing this wheel. You're probably looking at this saying, what's he going to do? The shaft isn't sticking out. Well, I got a solution for that too. Here it is. This is an M8 12 millimeter diameter standoff. Stock axles are 10 millimeters with M8 nuts on it. So pull this wheel back off. I can screw this straight onto the stock axle. I have a 12 millimeter bearing in there, and I can put that right on, and it lines up perfect, flush, ready to put the nuts and thread lock on. Now, I'm not ready to install this yet because I want to run the wiring first, but I did want to show you guys because I'm pretty excited about these. So are the kids. I don't know who's more excited, me or the kids. That's the front. The front's the hard part. The rear, seriously, I could have just cut the hole a little bit bigger for where the motor sticks through the body, which is all I did in the back, and put this gearbox right on and ran the stock tires. And this was a direct replacement. Everything just fit. Front needed a bit of designing. Rears were good to go. So if you have one of the rear wheel drive ones, everything just kind of lined up and these just kind of work. Because I wanted to do the all-wheel drive build, making things a little bit more difficult for myself. All right, next step, I'm going to throw wiring on here. I'm going to do 12 gauge to each of these motors because I really can't be drawing more than 15 amps continuously per motor. I'm only designing the wiring system in here to handle 60 amps. Hopefully I stay below that limit. I think I will because it's such a light car. These are going to be geared kind of low. I think we'll be fine. Important thing to remember when doing this is this stock throttle pedal. This is the stock throttle pedal. The two wires coming into this, these need to be shorted together in order to get the battery negative common signal, from the controller to the gear selector switch and back to the controller. So remember to pull these off and short them together. You cut it and strip it, terminate it. I'm going to pull all this stock wiring out here and try and reuse all those locations for the front motor wiring. One that I found is this is one of the motor wires that got pinched pretty bad while assembling it in the factory. That probably doesn't draw enough current on those little tiny motors to be dangerous in any way. But if I were to try and run the big motors and not replace this wiring and didn't check this, which I don't recommend you run any motor bigger than stock on the stock wiring ever. But don't try, especially because stuff like this can happen where it gets pinched in the bodywork. That would get really hot and would probably melt. Probably wouldn't catch on fire, but it definitely could. So remember, replace your wires. First motor soldered on, got the wire run from the controller general area. I did make some 10 millimeter to 12 millimeter spacers because these gearboxes are meant for 12 millimeter shafts and these are 10 millimeter. So yeah, I made a little spacer, just 3D printed, PETG. Should be fine. We'll see. I don't think it'll be an issue. I mean, it's not like rotating or anything. And I'm just going to apply a little bit of medium strength Loctite to the threads. And then I'm going to put my 12 millimeter, I think this is like 30 millimeter long. I got a whole bunch of different sizes. These RS775 gearboxes are almost a direct fit. Oh, I did forget to mention when I was putting that first motor in that this hole doesn't quite clear the gearbox. So, you go to put it in, you're going to have to remove some plastic. Easiest way is 1 3/4 inch hole saw. Just going to chop out a little bit of plastic there and get this motor fitted. And just a couple seconds with that hole saw. That gearbox is good. I don't want to push it all the way in. If you were doing this install again, just using these gearboxes, you would have to cut out this whole thing so it goes flush here to use the stock wheels. Since I'm not using the stock wheels, instead of making a spacer driving out to the wheels, I put this spacer to space the gearbox out, and then put the gearbox in, and then it's kind of rests against the body, rests against that spacer. It's going to hold it level, and then it's just less distance between the rim and the gearbox. The only reason I was doing that. If you're doing this and you don't have a 3D printer to change from 10 millimeter to 12 millimeter, not a big deal. I have run all the wires out here. So these are the passenger side motor wires. I have passenger side motor wires, front and rear. They're going to go to one channel. Out the other side, I have the other side just to keep them separate. This is a power cable coming from the battery. So I have two DeWalt packs wired in series here. So I have one, black to red, and then the black to red coming out here. So I'm going to get about 40 volts between these two wires. I ran out the plus, this is the plus 12 volt, the red, the black's the negative to power the lights. And then I have yellow was reverse and green is forward high. And then I have the throttle pedal. And then I'm going to get those wired up into the controller. And then I'm going to bring the other two motor wires to the other side. And then I'm going to shove everything in the back here and figure out a way to mount it and hold it in place. I have controllers powered up. This should just work. I shouldn't have to log into anything. The way I have it wired up, this should be forward. That motor is the wrong direction. This one's spinning forward. Switch it around. This one's going reverse, that one's going forward. So, front motor, I did wire one backwards, and I remember it being this one. So, gotta switch that polarity, gotta figure out which of these is the forward front motor, and swap these wires around. Remember, always unplug it and de-energize it before you start touching it with a screwdriver. Okay, this is the rear motor, so this is the correct polarity. So I'm going to swap this one around and try and keep these straight. I'm going to do positive first and shove this back in the terminal block. So these terminal blocks are designed for up to 6 gauge wire. So shoving to 12 gauge isn't too bad.
Wireless connection.
Both are forward. Both are reverse. Perfect. I am going to log in real quick just to make sure that I have forward and reverse right in the app, but I'm fairly confident it's right. All right, that's forward high. That's reverse. Perfect. All right, all 4 wheels are turning together in the right direction. All right, that's still set to 100%, 40 volts going into 24 volt motors. People tell me all the time that they run these motors and gearboxes 100% power on 40 volts. That quick blip of the throttle, I smelled burning motor, so we're probably not leaving it at 100%. But seems fine so far. All right, I'm gonna get. It's again late. This is my 3rd night working on this in a row. So tomorrow night, I'm going to get the 4 wheels put on it, and then I'm going to wrap up the LED lights that I have planned. So that's going to be using an ESP32 with a program called AWD installed on it. It's really easy. Anybody can do it who knows how to use a computer. You just buy one of these microcontrollers off Amazon and you install a program. You go to WLED.com, you plug it into your computer and you load it, and then you just log into it the exact same way you log into my speed controller. My last night of recording, doing the push buttons, wiring up these push buttons, doing the underglow lighting, which is actually not working at the moment. I need to fix it. The microphone didn't pick up any of the audio, so I'm just gonna kind of give you a brief summary of what I ended up doing here on the last night. I ended up having to, trim the fenders to clear the rims. It does hit just a little bit here in the front. Not too bad. I had to do both sides. It doesn't look too bad. Rears were good. Didn't really have to modify anything on the rear. No trimming, nothing like that. I have the rear tires off just because I have to rewire the LED strip. I have it hanging here to work on it. It was working, cut out. I didn't secure it properly. My fault. I did run dual 6 amp hour, 20 volt. So these are the flex volt, 60 or 20 volts. They're wired for 20 volts. The adapter will basically tell you which voltage it's going to put out. So if you're running this with a Speedy Squirrel, get the 20 volt adapter. If you get the 60 volt adapter and plug that in, you're going to see some fireworks. Please don't do that. Quick recap. We did push button. So this is to the on-off wire. So V in plus to the on terminal on the speed controller. So this is feeding battery power into the controller. The LED that lights up to tell you it's on, that's wired to the 12 volt output of the speed controller. So once you give it power, you get 12 volt out, that LED will turn on. And then same with the LED side. It has the, on the output side of the 12 volt switch, it's wired to the 12 volt LED. So you push it, you get 12 volts out of the switch, you get 12 volts into the LED, and you get that LED indication. It's pretty basic. I must say that installing the throttle pedal in this car was the easiest one I've ever done. I didn't have to trim a single thing. It just fit with the adapter plate. That was phenomenal. I hope you guys found this video useful, especially if you're trying to upgrade a car using one of these style controllers. These things are really low power, a max 35 amps, and that's real. That 35 amps really is a maximum. I see so many people having issues with these once they try to modify it. Stock, I think they work okay. Modified, you're out of luck. I'm gonna end the video off right here. I hope you guys enjoyed this build, and if you are interested, reach out to me. I'm gonna try and get all these 3D printed, everything I've used in this build that I 3D printed myself, I'm gonna try and get up on Thingiverse or on my website or in the YouTube video description. I might post the video before I get it all organized because I've been printing these parts over the last month. Like, I've had this car in my office just torn apart for like a month, you know, printing different rims, different adapter plates, getting the depth right, just right so the wheels fit. It took me a while. So I hope you guys enjoyed it. I know my kids are enjoying this car, as you can tell by how dirty they got it in one session. It did end up doing about, we had half an hour runtime on the speed controller. We only got to ride it for one day. It's been snowing a lot. Unfortunately, that's all the time that they could get in it. They really liked it. They could go through the snow pretty easily. You know, it was pretty impressive what this little plastic car was doing versus what it would have done stock if they actually got to drive it outside before I disassembled it. If you enjoyed this video, make sure you subscribe to our channel. I have quite a few more builds coming up. I have the pink Corvette and the McQueen to modify, and I have the Jeep. We are going on a trip here shortly, and those are the 4 cars we're bringing with us, and we're going to a couple different tracks and doing some different races, and I got to get those 4 built, and this was the first one I finished. So follow along. I'm going to have some pretty unique changes to each of them. I'm going to be doing things a little bit different than any of the other drag builds I've seen. Very similar, but a little bit different. So I have a different braking system that I'm going to be dropping in these cars, which if they disable power, it's going to automatically just apply a mechanical brake and stop the car. And I'm going to be doing different motor setups, and I have a different speed controller setup. One of the big things, I'll just give you a sneak peek, design this drag style rim. I really like it. It is heavy, so this is going to require a pretty beefy gearbox in order to handle this. You know, this is a go-kart rain tire, so tons of traction, and you know, this weighs a lot more than a stock tire with foam on it, since you know this is an actual racing tire. We have that, and we have our own wheelie bar, which we basically just took Alex Teeter's and then 3D printed the brackets so that you don't have to fabricate stuff, and then we'll make those. When we get to doing that video, we'll make those files available for everyone so they can print them on their own too. All right, make sure you subscribe and follow us, and I'll see you in the next video.